In the last video, we went through the basics of nomenclature and we looked at some of the common functional groups that we could encounter in looking at ranking their priorities. There are other common non-functional substituents, as in they don't really have any reactivity. Okay, so they have relatively minor interactions with their environment, and so they are, for the most part, named as substituents exclusively. If we take a look at the list that I've got marked down there, your ethers and your halides, you'll notice, don't have any other option. They are always listed as a substituent. Okay, and we can see that because they always are followed by a dash. Okay, so the common substituents that we might encounter would be the ether, the halide, and the nitro functional groups. Okay, all of these are relatively neutral, and so we don't want to name them as a kind of higher order functional group. We'll name them as a substituent. So with that in mind, take a minute to draw out the structure for that last one over here, and then come up with the names for the first two. And we're back. So we will start with the name for the first one. We want to identify our longest carbon chain. Okay. Another common mistake for students to go, 1, 2, 3, 4. Well, oxygen is not part of not a carbon, so it can't be part of the carbon chain. So we're going to end up with 1, 2, 3 as our primary shape, or our primary, not our shape, our primary main chain. There we go. So we're going to go with a prop. Since we have no higher order functional groups beyond the alkane, we can even drop in the ending on this. We will have a propane. Okay. Now what we want to do as our step 2 is identify our substituents. Okay. I have a methyl, and I don't want to write it that close to the wall there. Call that a methyl. And then we have the ether functional group, which we'll name as the alkoxy. So the oxy is referencing the oxygen. The alk is saying how many carbons are attached. Well, in this case, there's one carbon, so we would reference this as a meth oxy substituent. Okay. In step 3 of this naming system, we would then go through and number. We're at 1, 2, 3 with our propane. We have the methyl located at position 2. We have the methoxy located at position 2. And we can put our whole name together, deciding on which one comes first. Alphabetically, we'll run into the methoxy first. So we'll have 2 methoxy dash 2. And I think I just barely squeezed this out. Methyl propane. And we've got our first one named. Not too bad. How about the next one? You'll notice that we've got some changes going on in here. We've got this weird wedge and this dash going on with it. We haven't talked about that yet, so don't worry about it. Don't stress. Still find your longest carbon chain. We will go 1, 2, 3, 4, 5 carbons. So now that we know where my longest carbon chain is, I will circle it. With 5 carbons, I've got a pentane as my name. I'm going to run out of space again, so we'll stack this one. All right, I want to identify my substituents. I have 1, 2, 3 things not already circled. I've got a methyl. I've got another methyl. And then I have the bromo. Next step is to figure out our numbering system on this. We want to number in the way that gets us to our substituents fastest, which is going to be right to left. So we're going to have a 2-methyl, 3-methyl, a 3-bromo. Okay. Putting it all together, I would end up with, as my final name, 3-bromo, as B comes before M, 2, 3, whoops, not another comma, dash dimethyl pentane. And I now have the name for that structure. Okay, kind of dandy. We move on to the next name to structure system, again trying to identify some information here. I would, like I said before, I'd probably start at that hex knowing I've got 6 carbons. Before I completely start going crazy and drawing out my 6 carbons, it is helpful to make sure I don't have some extra information, say like that it's cyclic. So in this case, I know I have a cyclic structure, so I want to draw my cyclohex structure. The ane part of that name references something about the hybridization. The ane means I'm looking solely at alkanes, which means no double bonds or triple bonds, so I've got that settled. Going back then to the rest, it's now just identifying where the individual substituents are located. I've got a nitro group. The nitro is referenced as an NO2. Okay? Nice of me to have shown that structure earlier, isn't it? And then I've got the chloro substituents. Well, the chloro is short for chlorine. Okay? So, according to the name, I have 2 chlorines at position 1. Okay, well, where is position 1 on the ring? Doesn't matter. I can put it anywhere I want. So I'm going to put my chloros at these positions. Okay, yes, those are C's. Okay, and then at position 2, I have a nitro. So position 2, nitro. And I now have the structure for 1,1-dichloro-2-nitro cyclohexane. So it's just a question of kind of compiling the pieces, putting it all together. Okay. Moving on, you may encounter, when you look at your alkyl groups, some common names show up, and sometimes these are referred to as trivial. Okay, they're anything but trivial, but that's what they're referenced as. So the system, if you remember from the previous video where we had that 2-methyl propyl structure, that is your IUPAC nomenclature system. You have to use numbers to reference it. We could have gone through and used a common name reference for that. So if we draw out what that substituent was, let's see, we had our 5-membered ring, and then we had, 3 carbons, and then we had a methyl coming off at position 2. So what we're looking for now is what thing characterizes that piece. So if we go through and look, we should find that what we are looking at in that case is the isobutyl group. So we could have called that structure isobutyl cyclopentane. Okay. The isobutyl name you may see pop up. How do you know it's isobutyl? Well, you've got 3 carbons in a line with a 4th carbon in the substituent. That's where the butyl is coming from. It's got 4 carbons. The iso part of that name is because we have this shape at the end of our structure. And I'd love to tell you it's something more than that, but that's it. You have that shape. The first time that that shape can show up is when we have 3 carbons. Hence, our first reference to our shape. We have the Iso Propyl Group. Okay, you might look at it as, actually, no, I have no idea. I have no idea where the iso comes from. As we go through and process these, the methyl group, there's only one way to arrange the methyl group so we don't end up with different systems. Same deal with the ethyl group. At 3 carbons, we've got all of our carbons in a straight chain, or we have that 1 carbon jogged back further on along our chain to give us the isopropyl group. As we continue to add carbons, we start to increase the different ways that we could connect those carbons on the structure, which means we get more and more complex possible common names coming out of it. This is typically why we tend to stop at 4 carbons when coming up with these goofy names. In the isobutyl, there's your iso group, which is only 3 carbons, so I need an extra carbon before I connect to the main chain. There's the butyl reference. The next 2 are known as sec-butyl and tert-butyl. So again, butyl because we have 4 carbons total in the substituent. The way I like to look at this, which is where I think it's actually coming from, is the sec butyl is sec because the methyl is attached to a carbon that is connected to 2 other carbons, known as a secondary carbon. So we have a sec-butyl group. Yes, I'm fully aware that shows up in the isobutyl system too. I'm choosing to ignore that because the isobutyl is in reference to the piece that is in iso group, for whatever the heck that's worth. The tert butyl is in reference to a tertiary butyl group, meaning where we have our substituent connected to our main chain, that carbon is tertiary, meaning it has 1, 2, 3 carbons connected to it. Cool. Tertiary for 3 carbons. However you want to choose to remember these names is up to you. Officially, you're not responsible for having them memorized. They just tend to pop up every so often. So make sure you know where to find these trivial or common name references so that when you do see them pop up, you know where to look for them. Worst case, you have the internet. Use Google. And that's the end of this short little video.